Okay, chapter 18.1, Introduction to Acids and Bases. We're also going to cover 18.2. Never use these methods, these two methods, to identify an acid or base in the lab. Just putting that out there. Never do this, okay? But if you can determine properties of acids and bases based on touch or taste,
Okay.
don't do that.
No.
But think about foods that are acidic, things that have citric acid in them.
Yeah.
They are sour, so lemon juice, orange juice, like all those things have citric acid, so they are sour. Vinegar is also an acid. Bases are bitter. Caffeine is a good example of a base. Now, touch. Okay, touch. Dilute acids feel like water but burn in open wounds or eyes. And dilute bases, they feel a little bit slippery.
Like soap.
Have you ever experienced that?
Soap.
Soap is a good one. Slippery. But it burns in open wounds or eyes, so don't get them in your eyes or hands. Okay, there. Electrical conductivity. Both conduct electricity, both acids and bases, because when you combine them with water, they dissociate, or they basically come apart into ions. And so the ions floating around in the water are going to conduct your electricity, because you've got positives and negatives floating around. Reaction with metals. Acids are going to react vigorously, and usually you see bubbles or gas. Example would be baking soda and vinegar. Everybody's done that, where you get a whole bunch of CO2 given off. Normally it splatters.
Or even just the lab you did in the last class where you took the magnesium with the hydrochloric acid.
Yes.
And that bubbled everywhere.
Now, bases, they don't normally react with metals because it has a metal in it.
Yeah.
And so that would be more of like a single replacement kind of reaction.
Okay.
Reaction with litmus. What is litmus, first of all? It's a dye used to determine if a solution is acidic or basic. So whenever you have a little strip of paper, it's going to have probably litmus dye on it. But acids are going to cause blue litmus to turn red, and bases cause red litmus to turn blue. And you'll see these colors associated with acids and bases all the time. Acids are always red color for some reason in diagrams and things, and bases are always going to be blue. Neutralization. When acids and bases are mixed together, they form salt and water. That is review, because your reactions in that little box on the bottom of your cheat sheets
Front,
says
side, bottom.
acid, base, you get salt and water. Okay. Water solutions. All water solutions contain hydrogen ions, so H+, and hydroxide, OH negative. You guys know what those ions are. Acidic solutions are going to have more hydrogen ions than hydroxide, because acids are made of hydrogen ions paired with something else. And basic solutions, they are normally some sort of metal or polyatomic paired with a hydroxide ion. So if you have more hydroxides than hydrogens, you're going to be more basic.
Okay.
Neutral are right there in the middle, and they contain equal concentrations of hydrogen and hydroxide.
Easy enough, I think.
Basic stuff. But let's talk about.
Made a pun.
I did. The hydronium ion is going to be used interchangeably with the hydrogen ion. Hydronium ion is just a hydrogen ion with a water molecule. So the diagram here shows you if you dissociate water, you're going to get a hydroxide and a hydrogen, but you could also get, if you have water with hydrogen, you're going to get that hydronium. So you'll see it both ways, and you'll see the hydronium, the H3O, on your cheat sheet, but just whenever you see that, make sure you know it's hydrogen.
Right. Means the same thing.
Okay, 18.2. You probably can't see that, but it says strengths of acids and bases. It's right behind our heads. Strengths of acids. If you have a strong acid, you're going to ionize completely, so 100%, or as close to that as you can. They produce the maximum amount of ions. So if you look at the top picture, you have a picture of, well, it's like if you were to take a microscope and see the hydronium ions and the chloride ions, you'd see that they are separated completely. That means they are good conductors of electricity. So look at the light bulb, it is very bright compared to the one on the bottom. So strong acids are very good conductors of electricity because there's more ions in solution than if you had a weak acid. Weak acids ionize only partially. Notice in that picture you only have one little tiny hydronium ion. The rest are all acetic acid or the acetate ion. Weak acids are poor conductors of electricity, so you have a dim light there. And that picture's in your book too if you want to get a closer look.
Open a book? What?
Strong bases are going to ionize completely. So again, a strong acid, strong base, they're going to ionize 100% into metal ions and hydroxide ions. And then weak bases, not bass, ionize only partially, so it's the same idea as with your acids. Some strong acids versus weak acids. We will talk about the pH scale in the next section. However, look at the top here, you've got some strong acids.
Deeper red color.
What would that first one be? Chloric acid, sulfuric acid, hydrochloric, nitric acid. Okay, and then you go into some of your weak ones. So the strong acids are ones that you've heard of: hydrochloric, sulfuric, nitric. Can you think of any that we use that aren't on there?
No,
Those are the
not
main
really.
ones.
Yeah.
They will eat through everything.
Yeah.
Weak acids are going to be things like acetic acid.
Formic acid. Yeah. Anything on that list down at the bottom under your weak acids.
So in that kind of gray, purpley section.
And let's go to pink to blue. It's going to be kind of gray.
Yes. Okay. Examples of strong bases. These are a lot of your really strong bases.
I see a pattern.
Ones that you will see often will be sodium hydroxide, potassium hydroxide, lithium hydroxide,
Those are the ones we use in class a lot.
cesium hydroxide, maybe. Barium and calcium and strontium we have used before.
Yeah.
But what's the pattern that you see?
They all end in hydroxide. They're all giving off the OH.
And they're all paired with one metal ion. So if you see a polyatomic ion paired with a hydroxide, then it's probably going to be a weak base.
Yep, because then it's got to get rid of 2 of those
Yes.
metals.
That is it for 18.1 and 2. We'll see you for 18.3.